In this troubleshooting example, we are trying to figure out why a newly installed packaging system is not starting. Of course, many problems may be indicated right on the physical hardware, such as drives or controllers. However, the hardware is most often hidden from view in a cabinet. We will assume that this is the case here, so we will instead rely upon the Studio 5000 Logix Designer application to help us get the system up and running. We begin by going online with the controller. Right off, we see that, in this case, the controller itself is faulted. So, opening the controller properties, we can look at the major and minor faults to get an idea of what might be amiss. Here we see that the problem is located on rung 1 of the digital output diagnostic routine of the Line 01 program. Once we have identified the problem and its location, we can clear the faults. Examining the offending routine, we find an errant JSR referencing the routine from wherein it lies, causing the processor to repeatedly scan the routine with no exit. We will simply delete this rung. Changing back to the remote run mode, we see that the fault does not return. Next, we need to verify that the hardware associated with our project is okay. In this example, we see that the I/O not responding indicator is flashing. Referencing the I/O configuration in the controller organizer, we can identify the problematic hardware by a yellow warning triangle. Notice that, in this case, an I/O module communicating through an adapter and the adapter itself are not responding. Thus, it may be surmised that, if we correct the problem with the adapter, we may resolve the issue with the I/O module as well. Therefore, we begin our troubleshooting by selecting the adapter. Dragging up the bottom of the controller organizer, we reveal the quick pane. Within the quick pane, we see an error related to connection size. Opening the adapter properties and going to the chassis size tab, we see that the chassis size in module is 3. Since we only have one I/O module communicating through the adapter, we need to set the chassis size in module to reflect the chassis size from General tab, which in this case is 2. We verify the desired changes by clicking the OK button, and then we apply the changes by clicking the Module Properties OK button. Returning to the I/O configuration, we see that the warning triangles are gone and, at the top of our project, the I/O OK indicator is solid green. Checking operation again, we find that our system is still not running. Now we begin looking more closely at the logic. Opening the main program status routine, we find that machine permissives have not been satisfied. However, notice that the power rails in the logic editor are not green, indicating that the logic cannot be scanned by the controller. We have already placed the controller in the run mode, so there must not be an instruction in the main routine that directs the controller to run this logic. Opening the program main routine, we add a jump to subroutine to the logic and download our changes to the controller. Now we can see that the subroutine has green power rails, but the machine permissives are still not met. Now we need to begin tracing through our logic to locate the problematic condition. To help us in this endeavor, we expand View in the top ribbon menu and select Toolbars. In the Toolbars menu, we select the Bookmark toolbar and click the Close button. Now we will be able to place flags as we trace through the logic so that we can keep track of from where it is that we've come. Selecting our output instruction, we place our first flag. Looking to the left, we see that the Line 01 Ready instruction is false, so we select it and place another flag. Right-clicking on the Line 01 Ready parameter and selecting Go to Cross-Reference, we are presented with a list of locations within our logic wherein the parameter is employed. We may now double-click the instruction that writes to the parameter to find out why it is not turning on. Placing another flag, we continue on with this methodology until we locate the root cause. In this case, we have faulted points in our output module because there is nothing wired to the points, but the diagnostics are enabled. To fix the problem, we disable the diagnostics for the points that are not in use. Returning to our logic, we see that the last output that we checked is now on. So we can remove its flag and, clicking the back button, we move back to the last related input and see that it is now true. We continue tracing back through our logic, removing flags for issues that have been resolved. Eventually, we get back to an output that is still not on. Now we need to trace back through the other condition that is not met. However, as we trace through the logic, we reach a parameter to which no instruction is writing. Now we look to the By Connection tab to discover if there is another parameter or tag that writes to this input parameter, and indeed we find that the parameter is connected to the drive's ready bit. Opening the controller tags, we locate the bit within the drive's input tag structure and verify that it is a 0. Looking through the structure, we find that the drive is faulted and, furthermore, the fault code is 59. The add-on profiles for many devices contain a certain amount of diagnostic capabilities for the likely scenario wherein the physical device is not readily accessible. In this case, the Drive tab for the PowerFlex 525 allows us to view faults and, as it turns out, fault code 59 indicates that the safety is open. Pulling out the Safe Torque Off button, we are now able to clear the fault from within the AOP and proceed back to where we left off in the logic. Now we again backtrack through the trace, removing flags as we go. Eventually, we find that when we press the Start button, the drive turns on and our problem is resolved.